Hello everyone, this is my proposal for using pistol shrimp species Synalpheus Regalis in the field of aquaculture for the use of marine eusociality research as well as use for other research. For some background, the snapping shrimp or pistol shrimp is an extremely unique marine shrimp, being most commonly found in temperate and tropical waters and coastal reefs. They belong to the family Alphidae, which contains hundreds of different species of pistol shrimp. However, compared to other shrimp species, the pistol shrimp has an extremely unique trait. As its name suggests, pistol shrimp have a unique enlarged claw that acts and sounds like a pistol when used, and the pistol shrimp will snap their enlarged claw shut. Their claw is snapped at an extremely high speed where high temperature cavitation bubbles and shock waves are produced. As for the uses of this mechanism, pistol shrimp will use this unique trait in order to stun prey or communicate with each other. These shrimp had widely been known to cause one of the loudest sounds in the ocean as a result of this shockwave. There has been extensive research into the acoustics and general nature of this unique mechanism in pistol shrimp. However, there's a particular species and group of pistol shrimp that has often been looked past. About 8 species of pistol shrimp in the Synalpheus genus have been observed to exhibit a unique eusocial colonization behavior similar to that of bees and ants. Species within Synalpheus that have been extensively seen to form eusocial colonies are S. burksii, elizabethae, philadelphus, rathbunei, chachki, microneptunus, duffii, and regalis. These species of eusocial shrimp are found in large groups among coral reef sponges, being found most commonly in the tropical West Atlantic reefs. The mechanisms of colony function revolve around serving and protecting the queen while subsisting on host coral and various detritus for nutrition. Similar to the behavior of bees, pistol shrimp communicate with each other for the collaborative effort of fortress defense and subsequent removal of invaders. Eusociality is often regarded as the highest form of social interaction, resulting in the function of many individuals for the purpose of a collective unit. The main mechanisms that determine eusociality are overlapping generations, cooperative offspring care, and division of labor. This unique behavior is relatively rare in nature, being seen most commonly in insects such as ants and bees. Although there has been extensive research conducted on the natures and drivers of eusociality, scientists are still trying to understand the rarity of this phenomenon. With the discovery of eusocial species in Synalpheus, a door has been opened for the potential of further research into the nature of eusociality. Of the truly unique eusocial species, eusocial specimens in the Synalpheus genus have the crown of being the only eusocial marine organism. As such, extensive research is needed to understand the mechanisms behind eusocial formation in the ocean compared to terrestrial ecosystems. The medium of aquaculture would be an excellent way to extensively study these unique organisms for the purpose of eusociality formation and other research efforts. Of the eusocial species, Synalpheus regalis would be the best species chosen for the purposes of aquaculturing. Synalpheus regalis would be the most obvious choice for aquaculture for a variety of reasons. Firstly, Synalpheus regalis has the most extensive research conducted upon it, making it slightly easier to transition it into an aquaculture setting. In addition to this, S. regalis has been noted to have the largest colony size out of all eusocial species. For methods of aquaculturing, there are a few unique challenges that should be considered. Firstly, the methods of production here are unique in that they completely revolve around the presence of a queen, which would require the strict observance and preservance of this individual if there are any hopes of aquaculturing. The methods of producing a queen snapping shrimp must be further researched as well, most likely involving the selection of a mature female. Additionally, there may need to be an artificial sponge in order to simulate the natural habitat of these shrimp, similar to the one seen on the right, which is most commonly used by pistol shrimp. Stimulating growth while also being able to enable the safe extraction of these shrimp will be key. The artificial coral and surrounding tank should be rather sturdy, as the combined snapping of dozens of shrimp may cause damage. These factors contribute to the admittedly costly and risky upkeep of these organisms, but further research on the nature of these shrimp might yield alternative methods. Aquaculturing these shrimp as opposed to observing them in the field would allow for a variety of experimental variables to be much more easily applied as opposed to an environmental setting. Relating to this, education and outreach regarding these unique organisms would be much more easily applied due to the unique nature of the survival and extraction of these organisms. Although likely not being able to be used as a personal ornamental species, further research of S. regalis may promote its use in solitary aquarium exhibits. The reliance on snapping in pistol shrimp poses a variety of implications in relation to their conservation status. For example, the ever-increasing presence of noise in the ocean has been known to alter the communication of organisms who rely on sounds such as dolphins. The same effect could possibly be applied to pistol shrimp, as one of their methods of communication involves snapping. This is especially important in a colony, as it largely drives the defense mechanisms present for the colony. If increasing anthropogenic sound were found to impact the communication of these organisms, intruders could easily infiltrate the coral sponge with little or delayed resistance. In addition to this, a study conducted by J. Emmett Duffy found that unoccupied sponges were nearly non-existent in areas where eusocial shrimp were common. This conclusion infers that there is a high competition between eusocial shrimp species in regard to host sponges. This has serious implications for the future of ocean acidification and general ocean warming, as they may threaten future sponges. If the health of sponges is threatened enough, these eusocial shrimp species will drastically be impacted by the relatively low available living space present in reef sponges. Aquaculturing of these shrimp will allow for the further understanding of these organisms, as well as the variety of challenges they face. The potential of aquaculturing Synalpheus regalis in the field of research can be described as a jack of all trades. Being able to be used for eusociality, acoustic, and sponge health research gives this species a variety of potential uses. Although the methodology of aquaculturing would need to be much more fleshed out, there is obvious merit and payoff for the successful aquaculturing of S. regalis. The nature of production, eusocial shrimp, and the optimal colony size of S. regalis makes this species a perfect fit when considering the mass production of these shrimp. Thank you for your time. And these are my photo references. And these are my other references.